The problem says that what would be the height of the atmosphere if the density were constant and if the density will change like decreasing constantly. So first we are going to solve if the density were constant, that is the easiest one. So we have like pressure 1 minus pressure 2, it's going to be equal the density times the gravity times J2 minus J1. So we know that J1 must be 0 because it would be the height of the floor and it's on origin, so it would be 0. And J2 it will be the height of the atmosphere, but pressure 2 also is going to be 0 because at the end of the atmosphere the pressure is equal 0. So we have like pressure is equal to density times gravity times H. So now we can substitute because all have the values. The pressure is 1.013 and the density is 1.3. So we're going to substitute and we are going to solve for H first. So if we solve for H, it will be density times gravity divided by pressure, and if we substitute the values, it will be density, it will be 1.3 times the gravity, that is 9.81 divided by, no, I make it wrong. If we solve for H, it's pressure divided by density times gravity. So H would be 1.13 for this divided by 1.3 times 9.81. So if we solve that in our magic calculator, it must be 7.81. So it gives us 7,943.23, but that's in meters. So we have a smaller number. So if we divide that by 1,000, we will have like 7.9 kilometers. So the atmosphere will be this high. So that's in the part. So then we are going to solve if the atmosphere will change constantly. So we have that the A, B. The probably we're going to use the same equation but in a different way. So it will be pressure 1 minus pressure 2 equal the density times the gravity times the height. But we are going to change this because we are going to have like an integral, because we are going to take all the values like are in the atmosphere, like every slight piece of atmosphere. So we have to take an integral from 0 to H, and we are going to put Dy instead of H. So, but also the density, we are not going to use like this density like in the first problem, because it's going to be changing constantly. So the density will be the initial density times 1 minus the height divided by the H. So we now can substitute this density in here so we can solve the problem. So I'm going to pressure 1 minus pressure 2 equal the integration from 0 to H, the density times gravity times 1 minus G divided by H. So now we can solve this anyway. So we can divide this. We are going to split this into, it's going to be P1 minus P2 equal density times gravity integration from 0 to H dH dy minus initial density times gravity integration will be divided by H integration dy dy 0 to H. So now we split this so it will be easier to solve. So then we're going to start here. So pressure 1 minus pressure 2 will be equal initial density times gravity. So this will be H minus initial density times gravity divided by H, but the interval of this will be G squared divided by 2. So now we can solve this. So if we can add this, so we have a smaller number. So we have like pressure 1 minus pressure 2 will be equal we're going to put no, I'm making it wrong. Zero initial times y divided by h, but it's h splits with this. So this h my God. So we're going to add this up, so it will be a half of gravity times density times G times H. Here is H squared, so we have like this H gets with this, so we have like density. So this part will be the same as initial density times gravity times H divided by 2. So if we add this minus this, we're going to have like this is minus this. No, it will be positive. It will be positive. So then we have like pressure 2 must be pressure 1 minus a half of gravity times initial density times height. So now we can solve for pressure 2. Hey. No, very nice. Pressure 2 must be equal. The pressure 1 will be, no, we are going to solve for H. So we know pressure 2 must be 0. 1/2 of gravity. So H must be pressure 1 divided by a half of gravity times initial density. But this half, if we can put like 2 pressure initial. So if we substitute these values with the values we have since the beginning, we have that 2 times 1.81. And if we solve this, we are going to have like 2 or so the answer is 15,886.5, but it's in meters. So if we divided this by 1,000 like in the other, we have like the answer is 15.88 kilometers. So that must be the height if the density will change constantly. So that's all. Bye.